Welcome to Geography Optional Classes by PSO. So today I'm discussing the strategy related to the Unit 1 or Paper 1 that is called Geomorphology. So how to go with the Geomorphology and what are the focused area and from where and how you have to connect all the topics of it. Before getting into this let's discuss the syllabus out of it. Like as the syllabus given by the UPSC, it says that it has these following areas like factors controlling landform development, endogenetic, exogenetic forces, origin and evolution of the Earth crust, fundamentals of geomagnetism, physical condition of Earth interiors, geosynchronous continental drift, isostasy, plate tectonics, recent views on mountain building or volcanicity, earthquake, tsunami, or concept of geomorphic cycle and landscape development, inundation chronology, channel morphology, erosion surfaces, slope development, applied geomorphology in the fields of geohydrology, economic geology, and environment. So how you connect this topic and from where you can cover these topics and what should be the method used in it. And after understanding the different dynamics of the geomorphology unit, we try to see the past year questions which came on geomorphology and try to connect with these topics. Okay, so if you analyze the topic of geomorphology, you can divide into three major sections actually. Entire geomorphology, this geomorphology. First, understand the topic name itself. Geo means the land, morph means the form, logy means the study. That means you have to study the landform. But study of landforms technically is called as geomorphology. So how we have to understand the landform? So the landform you have to divide into different orders, like first order landform, second order landform, or third order landform. The first order landform is those landform which is a very clearly distinction between the two different type of earth crust actually. So the first order landform we call as the continents and the ocean earth surface, right? Continents and the oceanic surface. We already know the continent is what? The uplifted landmass, and ocean is the down areas which filled with water, isn't it? So how the oceanic crust develop and how the continental crust develop. The landmass which is above the sea level we are defining as continents, isn't it? Or the land masses. Now, world today is made up of 7 major continents. One is also there called Zealandia, and the oceanic crust are filled with water. There are 5 major oceans. The first question comes out about its origin. How the continental crust and oceanic crust evolved actually. Oceanic crust, origin, and then in the period of time, long geological history, these land, both the continental crust as well as oceanic crust undergo deformation. The past crust and today's crust of both continent and ocean is not same type. So the first and the most important topic emerges origin and evolution of the crust. Okay, in order to explain the origin and the evolution of the earth crust, so the forces from inside is important, called endogenetic forces, is it not? So the endogenetic force, the role of earth internal energy that is driving the force called endogenetic forces, and forces in geomorphology is also called by the word processes. So these is pushing the land from earth interior to develop it. So the role of endogenetic forces also came into picture. Once the endogenetic force came into picture, whatever the crust, continental or oceanic crust generate, it undergo a transformation, and then the transformed land or transformed body crust will become the second order landform or second order relief feature. And second order relief features the byproduct of the action of endogenetic process or forces, and these are maybe mountain, maybe a plateau, maybe a plain, maybe any kind of valleys, etc., etc., all kind of features you can put. That means volcanic landform produced by earthquake, produced by volcanic eruption, all come under second order relief feature. And this is the original irregularities produced over the continental crust and the oceanic crust. Now these second order relief features further get transformed by the outside forces. Outside forces is nothing but exogenetic forces, and the order of the relief which is produced by the action of outside or exogenetic forces we call as the third order relief. So now what is the action of outside processes? Outside process nothing but denudation. Already existing landform over the continent and ocean undergo degradation. And who do the denudation exercise? Denudation is done by different agents. The agents may be running water, wind, glacier, or the coastal sea waves and so on. So these actions produce the either erosional landforms or depositional landforms. So the agents produced landforms is only called as third order relief feature. So a river created landform we call fluvial landforms, or the wind created landform called Ionian landforms, or moving glacial produced landform we call glacial landform, marine action produced landform called coastal or marine landform, and so on. So these are relatively smaller size than the first and second order relief features. So it becomes important in your syllabus. Now there are not only endogenetic and exogenetic forces responsible for its formation. There are some other factors also plays in the formation of landforms. As a result, your syllabus contains these things. Factors controlling the landforms. So what are the factors that control the landforms? So factors, if you look at the factors controlling landforms, you can divide into around 10 major factors. First is the structure, the land itself, geological condition of the area, hard rock, soft rock, igneous rocks, metamorphic rock, how the rocks are arranged, horizontally arranged, inclined or vertically arranged. So on the relative weathering erosion take place on it. So second important factor is the process. Process is the mechanism by which the landforms get transformed, isn't it? So maybe by endogenetic forces or exogenetic processes. Third is the time. Some geomorphologists describe there is a sequential changes in the landform development. It passes through the three different stages. First stage called after the land upliftment called youthful stage, then enters into mature stage, then old stage. And this concept given by Davis, he called as cyclic theory of landform development. Okay, or also called cycle of erosion, isn't it? So we will read the Davis one. And there is a contemporary is also there which criticize cyclic or the sequential landform development like Penck, isn't it? Or system analysts like the Stoller or H.T. Hack. So they criticize the time concept or sequential concept. Apart from structure, process and time, landform also byproduct of relative rate of forces, isn't it or not? So rate of endogenetic and exogenetic forces. So here the pen talked about both the forces are acting to create a landform. So from endogenetic forces is pushing the land for upliftment, and the exogenetic forces is responsible for degradation of landforms. Once the landform at any point we want to observe is is the byproduct of interaction of both the forces. If endogenetic forces are more powerful than exogenetic, landform is under the waxing phase, means the accelerated rate of landform development take place. And when both the forces are equal, endogenetic and exogenetic, the landforms enters into the state of balance. No changes in the landform in a span of time you observe. Third, if the exogenetic forces dominates, then the rate of endogenetic forces, then its land undergo degradation, and same as the cycle of erosion given by Davis. Now, fifth factor for the landform development is the climatic factors. Okay, sometimes the climate describe the rate of weathering. Both Davis, Peng, and other geomorphologists say outside forces denudation is controlled by climate factors. Climate is nothing but temperature, rainfall, isn't it, or the up humidity, etc. So the rate of weathering controlled by the type of climate that region possesses. The hot humid weather condition has one rate of weathering denudation than the cold temperate areas, and humid areas has one than the dry areas. So different climate produce different type of landform. This concept will produce the zonal landforms. These may be the questions may be created like climate control landform we call zonal landform. You may get a question on here also. Next, the factors. So today's the modern theories of landform development does not much talk about endogenetic, exogenetic forces, but about the slope modification. Slope modification theories become new theories of landform development. So the slope, existing initial slope will decide what is going to happen with the possible. We know there are steeper slopes, gentle slopes. So already existing steeper slopes undergo deformation because of the slope decline, because of the slope retreat, because of down wasting, back wasting, and the parallel retreat given by the Peng. Now slope modified, what will happen? The gentle steeper slopes has to convert long period of time into a gentle slope, and low land will be created out of this. So now what label these landforms are being eroded? Okay, high landform converted into low landform, that is nothing but up to the base level. If base level is changed, your landform evolution cycles of erosion get disrupted. So base level or sea level remain constant, your landform also remain in the same rate of erosion will operate. Isn't it? So base level has to remain intact, isn't it? So now Davis cycle of erosion to complete base level or remains intact in sea level should be in a constant form. But due to climate changes, due to tectonic changes, base levels are changing. So and because of that, you will have the rejuvenated landforms. Again and again, the lowland get raised, and that undergoes cycle of erosion. Then cycle of erosion will convert that highland into lowland and up to the base level. And again, this is polycyclic landform, second cycle of erosion that develop, isn't it? So rate of weathering and denudation in any area depending on amount of vegetational cover over it. When the cover is more and more, then the outside forces actions are less and less eroded, more protected land from the erosions, and the devegetated areas actions are more. So accordingly the landforms get developed. So the soil erosion, so these are the important factors. So now human today is also triggering the landform change, slope modification. Okay, so the human effect on the landforms in the recent time because of technology, because of more direct and indirect interference and involvement, is more and more, that is transforming the land in large scale. Is it landform is only controlled by these factors? It's at one area, one kind of process are dominating or mixing of all this. So we say factors that control landform is not one. It's an entire landform development is a complex process. Okay, that's why your landforms get evolved. So that's what your syllabus look like this. So factors controlling landform development, endogenetic and exogenetic forces, origin and the evolution of Earth crust. Okay, now we are dividing the syllabus on the basis of the topics. So major three themes. Okay, major three themes your geomorphology in its work. First is about the tectonic geomorphology. First is the tectonic geomorphology. So here in tectonic geomorphology, the process is more important. Okay, the tectonics are more important. So that means tectonic geomorphology basically talked about what called the Earth internal things as well as the motions which is happening inside the Earth. So movement of the Earth interiors, isn't it? That's causing the tectonic geomorphology. So the tectonic geomorphology is due to the what called movement of the Earth interiors. Okay. So movement of the Earth interiors you can define by continental drift. You can define on the basis of plate tectonic movements. You can, if when activities from Earth interiors is very fast, then you will generate endogenetic forces. And within the Earth interiors, it's so strong, it can have the volcanic eruptions, volcanic activities, or the seismic activities, or also called earthquake. Major earthquake and volcanic activities underwater can trigger the tsunami waves. Okay, Earth from interiors is consisting of three layers, like interior is the core, and the middle part is called the mantle, and the outermost part is the crust. And so the layering of the three parts internally, we have three layers, and this becomes the physical condition of the Earth interior. So if with the knowledge of earthquake wave or seismic wave, we can determine the Earth internal physical condition. So the topic becomes physical condition of the Earth interiors. Okay, now not only physical, once you know the physical condition of the Earth interiors, you can came to know that middle layer is mantle, where there is energy difference that produce thermal convection current. Thermal convection current is responsible for both continental drift, plate tectonic movement on the Earth surface, endogenetic forces, volcanic activity, earthquake, all might be powered by Earth internal energy that has been transferred by the thermal convection current given by Ohms. You can understand certain concept like thermal convection current given by Arthur Ohms, isn't it? And this is powering the continental drift given by the Wegener. Even it can also explain the seafloor spreading, which is the scientific evidences for the plate tectonic movements. If you study further deep the Earth interiors, you will find the core is inside is not one type. The solid core inside surrounded by a liquid outer core. So the two cores are there, outer liquid core and inner solid core. So the outer solid core, okay, outer solid core contain nickel and iron in solid form, and the sorry, this is written as inner core is in the solid form, right? Inner solid core surrounded by the outer liquid core. So outer liquid core also contains nickel and iron, and which is under motion due to the rotation of the earth, isn't it not? So it conducts the electric current in fluctuating manner, behave like a dynamo. So earth outer liquid core behave like a dynamo, produce the earth magnetism. Earth magnetism of present have some significance. That topic become fundamentals of geomagnetism. And if you study the past history about magnetism, you will have the branch called paleomagnetism. So you can find out the magnetic properties of the earth of the ancient times. So that is stored in the rocks. So by doing the survey of rocks magnetic field, you will find out three properties. That is, one is the intensity of earth magnetism, inclination of the magnetic or called magnetic depth, or the declination. When three properties of earth magnetism studied by the paleomagnetic scientist, will trace out the entire paleomagnetic history of the earth. On the basis of that, it become a technical and scientific evidences for continental seafloor spreading plate tectonic movement, isn't it? So the magnetic poles is not same, keep on flipping once against the another. So you will have paleomagnetic studies also in your syllabus. Is it fine to everyone? So it's a tectonic geomorphology, and because of endogenetic forces, most important feature which develop on the Earth's surface is the mountain and mountain building process called as orogenesis. So it is what called orogenesis. So orogenesis, the old method to prove how the mountains get developed. So it is found out that they are developed from the sea or ocean, and that branch is called as geosyncline. The geosyncline or from the oceans, only all the mountains get developed, and from which ocean is shallow water body. So this also giving you the concept of geosyncline, the old view that explains the mountain building process. You may get questions on geosynclines. The shallow water bodies between the hard rock structures, stratozones, and the new views that can explain the mountain building is nothing but plate tectonic theory. So in the syllabus there is a recent views on mountain building or orogenesis. When you're dealing with the recent views on mountain building or orogenesis, you have to explain using plate tectonic theories the development of Alps, Himalayas, Rockies, Andes, and so on. It can also explain volcanic mountains, block mountains, folded mountains, all you can explain. So first theme where the questions are arising is from tectonic geomorphology. Second theme on which the questions are arising will be from the structural geomorphology. From the geomorphology called structural geomorphology. So what is structural geomorphology? It is also related to the land form, slope development of the region, or the land form development of any region. How does it transform with the time? So you can see here. So first part, let me talk about factors for controlling landform development, endogenetic, exogenetic forces, origin and evolution of the earth crust, fundamentals of magnetism, physical condition of earth interiors, geosyncline continental drift, isostasy, plate tectonics. One, isostasy is a balance, how different landforms gravitationally or vertically balancing over the atmosphere. That is the concept of isostasy. stressy. So the Pratt view and the Aries views are important here. And the recent views of the mountain building is explained by plate tectonics. Plate tectonics also explain the hazards created in the geological disturbance like volcanicity, earthquake, and tsunami. So this entire this part from here to here is a part of which geomorphology, tectonic geomorphology. Okay, you have to study in one day. Second, from concept of geomorphology till the slope development that include the geomorphic cycles, landscape development, inundation chronology, channel morphology, erosion surface, slope development, it comes under structural geography. Is it come under which geography called? Structural geography. Structural geomorphology in detail. Okay. So nowadays the questions are not only asked on tectonic geomorphology and structural geomorphology, questions are shifting towards the applied part of geomorphology. The three sections you can apply geomorphological knowledge, geohydrology, economic geology, and the environment. That means how geomorphology can decide you the water system or drainage system, surface water, as well as the groundwater aquifer. So water potential of the area would be identified. So on the basis of that, water use will be there. It helps you to find out the water stress areas and the habitation accordingly, isn't it? Even economic geology helps us to identify the locations of mineral resources which has been distributed on the earth surface. It may be a metallic minerals or non-metallic minerals. Okay, or the minerals which is stored in the different types of igneous and metamorphic rocks, or found in different agents of innovation as a placer deposits. Some of the mineral resources found in the native form, some is found in the form of the sediments depositions. Isn't it like rare earth element placer deposit, gold alluvium deposit, or native form also been found. The knowledge of geomorphology is put into use in environmental sciences because large number of environmental issues are arising without understanding geomorphology. Clear? So like the hazards are produced, so you can understand how the hazards can damage it. Or especially the land is stable or slope is stable or not stable. So use in slope management, okay, that will prevent landslides and other casualties. Geomorphology will also help us to describe the type of soil area can develop. It's depositional soil, erosional soil, in situ soil, ex situ soil, okay, zonal, azonal, or what type. So on the basis of agent, you can define the soil. Soil means agricultural applications. And biocapacity of the region is also determined by this. So type of flora, fauna that land can support, isn't it? So how you can complete geomorphology? So what are the sources of reference for it? So the questions, if you observe, you can cover from one major source. One source is the read Savinder Singh's individual textbook on geomorphology. Okay, and second is the geomorphology. So in the physical geography of Savinder Singh, you can get concepts up to tectonic geomorphology completely, but there is less description on the structural geomorphology. For that, you have to get a separate textbook. Okay, and applied geomorphology is also good. And please refer to the class notes of mine to get this. Okay, now not only I am discussing about this, I will talk about certain question which has asked in the recent time on this issue, isn't it? So what are the things you can talk about. Let's discuss about the past year question papers. I hope the question paper might be visible to you. So these are the question bank has been prepared. So you have these things in your head. So you can Arthur Holmes convection theory, isn't it or not? Or the American schools of geomorphology, which discuss different geomorphic concept like Davis concept, isn't it or not? It's an American schools. Or even recent proofs for paleomagnetic studies done by the American schools, that also we talked about. If you look at this diagnosis, there are a lot of questions on each, isn't it? This all the landforms you can understand: fluvial landform, marine landform, glacial landform, periglacial landform, Aeolian, desertic, karst, polycyclic, or volcanic landforms. So these are the lists from 1990 till what? Till last year 2022 mains, isn't it? So last question, like, with the help of suitable sketches, describe the mountain genesis and mountain types. With the give suitable examples from various mountain systems of the world. You can do it. Okay, like they are folded mountains, block mountains, isn't it? Or volcanic mountains, or residual dome mountains. How the L series develop, or Rockies, Himalayan series develop, ND series develop. You can explain all on the different locations. So plate boundaries is the best thing. So we can discuss individual questions in the coming series. Thank you all of you. Take care. Bye.